And welcome back. In this tutorial, we're going to cover one of my favorite geometry creation techniques, and that is the rectangle tool. So we have the rectangle tool with a pull-out and a lot of different options underneath here. I'm going to cover most of these. Some are similar, like all of the different slot variations. So start off with at the top, we have our regular old 2-point rectangle. It's defined by 2 points. So if I wanted to start with the, let's say, lower left-hand corner of my rectangle, I can now type in 12, tab to change dimension boxes, 6, and now I have a 12 by 6 rectangle. When I hit enter or right-click OK, my rectangle disappears. That's odd. Let's try it again. 12, 6, enter. And so now I've got a all black, fully constrained, we see down here, fully constrained rectangle that is closed and ready to go. So I can then take this and extrude it. We're working on the front plane here, and I've got my basis for an extrusion. Now, the next one I like to use even more, and I'm going to project all 3 of my work planes, which is something we're going to talk about in a little bit. Touched on it, but I want to make sure that that's a habit that you guys get into. Next tool is the 3-point, and that one basically allows you to draw a rectangle on an angle. So if we wanted an angle of, let's say, 135 degrees, and we want this leg to be 2 inches, and then we want our length over here to be, let's say, 6. Now I've got my rectangle. It's not fully constrained. The size is fully constrained, but where it's located is not. So something that you need to take into account. Next is 2-point center, and I love 2-point center rectangles. I recommend my students use them anytime they're drawing a rectangle. The reason being is that it creates symmetry constraints as well as size constraints. So if we do a 6 by 3, now I've got these 2 hidden lines corner to corner. This rectangle is symmetric. The distance from here to here is the same as it is from here to here, and the same thing in the y-axis. Now, the good thing about this is that when I change my size, it automatically maintains that symmetry, which is really nice. So if we go ahead and delete all that, next we have a 3-point center rectangle, and that allows us to use a center point and then create 2 other points to create a rectangle. The slot center to center is a very good tool. All these slot tools are very good. The thing about these is that you have to set them up correctly. So it's kind of like painting in your house. If you take off all the switch covers, pull out all the registers, tape around, let's use a bathroom, tape around the toilet, tape around the sink, tape around the mirror, all that work tends to take more time than it does to actually paint the bathroom. I'm not a big fan of painting myself, but hey, you know, we have to do it. So if I put 2 points down, and then I create a symmetry constraint, and we're going to cover constraints in a little bit, but this constraint is going to make these the same distance on either side. I then dimension between the 2, let's call this 6, and now I come into my center to center slot, pick a point which is set, pick a point which is set, add my diameter of my arc, which we'll just go with 3 in this case, and now this is set. Then if I want to change it, I grab my dimension. I can change this to, let's say, 8. I can change this to, let's go with 4, and everything changes. My symmetry is all maintained. This is going to be really important when you are working with parts that you know are going to be assemblies or have mirrored features. So something to pay attention to. Go ahead and delete that geometry and get rid of those points. So slot overall works pretty much the same way. If we, actually let's undo that, let's keep our points. If we did slot overall, that's going to be the outsides, and then you're given the option for your diameter as well. So if you know the distance and you don't want to subtract the radius or the diameter to get the two center to center points, or you have existing geometry where this slot has to go between these two things, you can use that geometry to drive instead of using a dimension. So there's some pretty powerful tools in here that we can use. So we'll go ahead and get rid of this. So the slot center point is the same, except we're going to use different inputs. So we're going to pick the center of that, we're going to pick the center of our first arc, and then use our distance. So different options for inputs based off of your requirements. Now this one, we can go ahead and throw one more point in, and these arcs save a lot of time when it comes to creating geometry. So here we see that we're asked to pick 3 points, a start point, an end point, and then a third point. So if we pick our start point, our end point, and our third point, now we're given the option to put in, let's go with a 1-inch diameter there, and now we can see that we've got that slot, and then I can change any of the dimensions that I'm using to control this, and everything changes accordingly with it. So this is a really powerful tool. Our other option down here is, again, to have a center point, and this is the same as this. It's just, again, different inputs that you might have. And the last thing is going to be polygons. And polygons are good when you need to create something that's not a rectangle. So a lot of times in my application, we use hexes a lot. So you've got your number of sides, and then you can either pick inscribed or circumscribed. That's going to depend on whether or not you have existing geometry that you're trying to use, let's say with regards to a circle. So if we use a hex, typically what we do is we just pop it in on some angle. Hexes are measured across the flats typically. So let's say that we want to make this a 1-inch hex, and then I need to put a horizontal constraint on this line, and that's going to snap that. Again, I could have put a vertical constraint on this, and this line here would have rotated to end up over here. And then we can drag that to be in our center point. And that's how we create a hexagon. Thanks, and we'll see you in the next one.